Hello everyone, this is Susan and I'm back with another video for calculating the steam power index, which is one of the most powerful index in hydrological perspective study. So for that, we need a digital elevation model first, and based on the elevation model, there are few steps that we have to follow up to get the result. Okay, so yeah, I have my digital elevation model. I'm going to check the properties of the digital elevation model to check which projection system is there. For that, you can just go to properties and look at the source, and you can see in the special reference you can find that it is a geographic coordinate system in WGS 1984. So yeah, it is in the geographic coordinate system, so I prefer to work with projected coordinate system when I'm working with hydrological perspective. So first, I'm going to project this raster to some projected coordinate system. I think this is the digital elevation model that covers southern part of southern west south yeah southern part of British Columbia. So uh, I will be projecting this geographic coordinate system to project a coordinate system of WGS 1984. I think there will be two zones that included this area. One will be 10N and I think 1011N. So for now, I will be just converting to one specific projection coordinate system. So I'm just selecting this input, which is my input geospatial sorry digital elevation model. So yeah, you can always give the name for your DEM, and I'm going to give this as just DEM. Okay, so here for output coordinate system will be I will be going to click on this uh, what is that earth logo, and I will be going to the projected coordinate system. And since we I'm going to project it in UTM projection, I will just select over here and go to WGS 1984. This is what I'm going to do for now. And North America, yeah, the North America lies in northern hemisphere for sure. So yeah, after finding here, as reaching here, you can go and select this WGS 1984 UTM zone. It depends on which projection system that you want to use. For now, I'm using this, and you have to be very careful, like which area you are working, and you have to check in Google like which projection system, which zone is matching with the specific region that you are working on. So uh, I'm just selecting this one and click on OK. So this will be my projected coordinate system that will be projected on. So yeah, after projecting this digital elevation model, the resolution is coming as 24.62. You can always resample this value. Maybe if you want to work as a 30 meter per second, then you can give this value to 30. Then the digital elevation model will automatically resample to this specific size. Okay, you can always do that. So yeah, once you define this information, you can just go and hit the run. Once you hit the run, it will start working for projecting this raster to uh, projected WGS 1984 10 and zone. Okay, so yeah, it's done. And if you go and check your properties over here, you will find that under the spatial reference. So yeah, this is the projection system that we converted right now, and the APSC code is 32610 for this one specific coordinate system. So yeah, the first step is done, and the second step is we are going to fill the sinks. If there is any sink available in the DM, then I always prefer to fill sync so that there will be no problem with that. So for that, I'm going to go into the geoprocessing tool, and under the geoprocessing tool I will be going to the toolboxes and get down to the special analyst tool. Okay, and then you will have to go to hydrology section, right? So yeah, the first thing is you have to fill the DM so that there will be no holes and sink will be disturbing the overall analysis of DM. So I will be using this projected DM, and I will just give the name as field DM. That's all. And you just have to go and hit the run, and it will start working, and it will give you the result of field DEM. Okay, So let's just wait for a few seconds. I think it will not take time. It is a small area. Maybe. Okay, so it's working. Yeah, great. So yeah, we already got the result. So I always prefer to turn off the previous layer so that it will not create loads in the GIS environment. So yeah, now the next step is to calculate flow direction, because since we will be requiring flow accumulation, that's why I'm calculating field DEM and field flow direction. Then we will be calculating this what we call flow accumulation, and based on the flow accumulation we will be calculating the stream power index, right? So flow, for flow direction I'm just giving the name as flow direction. Okay, so flow dir, and you can always check which method you want to use. For now I'm just using this d8 method. There are multiple methods that you can always use. So yeah, this is d8 method, and once you give all the inputs, then you can always go and hit the run. And once you hit the run, then it will start working on its process to give you the result of flow direction. And once this flow direction is calculated, then the next step will be calculating the flow accumulation. Okay, so you might be confused, like why I'm doing this. So since I'm calculating the flow, sorry, stream power index, this is the requirement that you have to do. These are the steps that you have to follow. So yeah, these are the values that is computed for each cell having the resolution of 30 meter by 30 meter. Yeah, okay, then the next step is you have to go and calculate the flow accumulation, and you can find the flow accumulation here. You need the inputs, that is you have to provide the input flow direction, right? So you just have to select the flow direction that you calculated just now, and you have to rename like whatever you want to. Try to be more specific. I don't want to use any input weight raster. If you are using any such like maybe precipitation value or any other thing that you want to incorporate in this flow accumulation, then you can always add those weight raster. For now nothing is required. So yeah, and then the next step is to provide the output data type. um, it is considered as whatever type of data that you want to work on. You can always select one you like, but for now I'm going to select this integer value, because the flow accumulation is calculated based on the flow direction, and the flow direction is just providing the direction in which each cell is accumulating. So integer value will work here. So yeah, and similar to the flow direction, which type you had used in the flow direction, you should be consistent with that. Okay, yeah, once you input all those information, then you can just go and hit the run, right? It is so easy peasy, yeah. Anyway, once the flow accumulation is calculated, then the next step is, now you are going to calculate the slope. Okay, for calculating the stream power index based on the digital elevation model, you will need two input. That is, one is flow accumulation and another is uh, what is that? I forgot. Did I forget? Yeah, you for okay. Yeah. Oh, another is slope, and you have to be careful on calculating the slope as well, so that there will be no problem on calculating what you are going to achieve from all this data set. So for me, flow accumulation is taking a bit of time. Maybe my computer is slow. Anyway, I got the result. So I'm just turning off all these layers so that it will not provide me tension while loading all the layers. So you can see there are lots of values ranging from 0 to like lots of flow accumulation value. If you zoom in, you can find, yeah, this is the stream network that is defined based on this flow accumulation, right? So you can always generate stream network based on the flow accumulation. For now it is not our target, so I'm going to calculate slope. So what I will do is I'll just go to the source and I will just search for slope here. Okay, so yeah, you can see the slope under the special analyst tool. You can go there, input the raster. You can always select the fill DGM so that there will be no sink to disturb this one. And I will be calculating slope in degree over here because I'm using degree function over here, and I will just use this planner because I'm working on very small area. And in calculating, during calculation of the slope, if you have GPU, you can always use the GPU by its default as well. So yeah, so once you provide the input, you just hit the run and it will start working, and you will get the result of slope. The value of the slope is in degree. If you want to provide some symbology, you can always do that. For now, I'm not going to do that because it will take a lot of time. So I think you can convert this slope to radian, right? So yeah, is there any tool to do that? um I forgot the name of the tool. I think there was like some tool to convert slope into radian. Okay, I think let's just leave it. So what I will do is I will just calculate based on the value that we have to convert. So yeah, once you have this slope and flow accumulation, you can always go to further steps. So the next step is to uh, search for raster calculator under this special analyst tool. And now we are going to provide the formula for the calculation of the flow accumulation. So it's very easy. It is just simply flow accumulation into tan of slope in radian. Okay, so for that, what I will do is I will just go to flow accumulation, right? And I will be multiplying this value with my resolution value, that is 30, right? So resolution of the accumulation is 30 over here. Is there any problem? Well, it was not supposed to have any problem, but I don't know. Flow accumulation, what is it? Python syntax error, Python string line 1 raster, the map algebra expression that will be run. It was supposed to work, but I don't know why. Is it like, do I need bracket or something? I didn't notice that. Okay, I've come up with a formula, but I don't like why is it showing me. Is there anything like any problem with the data or anything? Okay, yeah. So this is the formula that we have to incorporate. Is you just go and click on the flow accumulation. This will be multiplied with the cell size, and it will be multiplied with the tan of slope. So slope is calculated in the degree, so we have to convert this value into a radian. So I just multiplied this value with 0.017453. Once you multiply this with this value, then the slope is converted into the what is that, radians. So yeah, once you feed in this formula, you can go and type SPI. I mean the name of the raster layer that you want to export. Since I'm calculating stream power index, so I just thought of giving this as a SPI. Once it is done, then click on run, and it will take some time, and it will give you the output as stream power index. So you can see the range of value is very high. So for this, to understand, what I will do is I will go and work with the symbology. You can right click on the layer, and you can always click on the symbology, and you can see the values over here. So maybe I will just use classify, yeah, so that I can see some of the ranged value over here. I think the value is really really very different. So okay, first let me just increase the number of class so that if there is any changes or differences that we can find out. And I will be using equal interval. Let's see. What happened? Why not equal interval? Okay, it was taking time. Okay, so let's just also let me also change the color. Okay, so if you just zoom in, okay, yeah, see, these red yellow colors are showing that they have like high stream power index, and if you find this color, then they have very low stream power index. So basically, um, if there is river network or lakes, then you will find the stream power index is higher, right? So you just have to zoom into the specific area, then you will find where the specific area is consuming a lot of accumulation of stream. So yeah, this is how you can calculate this stream power index. So yeah, thank you so much for watching till now, and if you have any confusion or any problem, please let me know, and thank you so much for watching.